I'm going to discuss the position of the physical layer at the bottom of the OSI model, introduce the functions of the physical layer, talk about some properties of physical media, and give a few examples of physical layers in use. The physical layer is at the lowest layer of the OSI model. This is layer 1. This is the layer of the conceptual OSI model on which all the other layers are built. In practice, this is also the layer that contains the networking hardware. The remaining layers can be implemented as software layers on top of that hardware. Functionally, the physical layer provides a fundamental base for building a network system. It is the fundamental layer that underlies any network. In most cases, the physical layer is implemented in hardware and primarily consists of hardware. There is a way that we can virtualize a network, and we can essentially simulate a network using a physical layer that's been implemented in software. But for the most part, the physical layer consists of hardware. This layer provides the basic communication channel that two network devices, such as computers, can use to send and receive messages. This layer includes the transmission and reception hardware, as well as the physical link between the devices. The purpose of the physical layer is to transmit bits. Now, in other layers we may talk about frames and packets and other types of data structures for organizing data that's going to be sent over the network. But at the physical layer, we're concerned only with transmitting bits. And we're transmitting these bits between physical machines, between different devices on the network. And physical layer's job is to take a stream of bits from one device, encode them into a physical signal, send them over a wire or over a radio, and then decode those bits from the physical signal at the other end in order to extract the stream of bits from the signal. It's also important for the physical layer to isolate different electrical or optical circuits from one another. In the case of an electrical circuit, for example, such as with an Ethernet network, a malfunctioning device on one part of the network should not be able to bring the entire network down by means of a short circuit or some other type of electrical malfunction. So the physical layer also needs to perform what's called galvanic isolation, keeping different circuits isolated from each other. Now, there are many types of physical links. We can generally categorize these links into either cabled links or wireless links. A cabled link has some kind of a cable running between the devices in the network. So here I have a couple examples. I have a patch cable, a category 5 patch cable. This is a type of cable that can be used with wired Ethernet networks, and this cable uses 8 pieces of copper wire to transmit data. Here I have an example of a fiber optic cable. This particular fiber optic cable is actually used more routinely in audio applications than in network applications, but the idea of a fiber optic cable is the same regardless of the application, and that is that it allows us to transmit light through a flexible piece of glass or plastic. Here I have an example of a wireless device. This uses a couple of antennas to transmit data over radio waves. Now, regardless of the type of physical link, all physical links have to take the bits, the actual digital signals or the digital messages that we want to send at a low level, and encode them into some kind of an analog signal in order to be transmitted over the link, and then decode that transmitted signal at the other end in order to receive the original bit stream. The most common type of analog signal that we use for this purpose is an electromagnetic wave. The reason why we like to use electromagnetic waves is that they typically travel at the speed of light through a vacuum, or relatively close to the speed of light through other materials, and so they're fast. Different types of electromagnetic waves can be used. We have electrical pulses over wire, radio signals that can be transmitted through the air, or pulses of light that can be transmitted through a fiber optic cable. It is possible to use other types of analog signals, however. We could use sound, we could use vibration, we could use pneumatics. Here I have an example of two soup cans being connected by a piece of string. We could technically send audio signals down the string as vibrations, and we could transmit data that way. We don't typically do this, however, because the speed at which the vibration moves down the piece of string is much, much slower than the speed that I could send an electrical signal down a piece of wire of the same length. So we'll typically use electromagnetic signals, but it is possible to use other types of signals. Now conceptually, in addition to providing the hardware, the physical layer also specifies certain properties of that hardware. So things we have to specify include the type of connection. Do we have an electrical connection? Do we have an optical connection? Is this a wireless radio connection? We need to provide specifications for what kind of cable or what kind of radio we're going to be using for the connection. For example, with Ethernet, we're going to specify with the modern Ethernet system that we're going to use twisted pair cabling. With fiber optic, we're going to specify a type of fiber optic cable. With the wireless network, we're going to specify a particular type of radio. We also need to give physical requirements for the connectors, the antennas, and any other attachments that are going to be used with these cables. So for example, with wired Ethernet, we have a standard 8-pin plug that we can utilize to attach different devices to the cable. If we didn't have standard attachments, it would actually be extremely difficult and relatively expensive to connect different devices together. So this layer is highly important. It could be argued, in fact, that the physical layer is the most important layer of any networking system, simply because none of the other layers work without it. This layer defines the communications hardware that's going to be used to implement the network, and every other layer of the OSI model can be implemented on top of it, and moreover, every other layer of the OSI model can technically be implemented entirely in software. So the software needs some kind of hardware on which to run. The physical layer provides that hardware and allows the network to function. So let's look at a few examples of different types of physical layers. In the case of wired networks, we have things such as the Ethernet physical layer for standard Ethernet connections between devices. It's not really so much a networking protocol in practice, although it can be used for this, but the Universal Serial Bus, or USB, does have a physical layer specification. Included in that specification is what a USB connector looks like, how it's shaped, and how it's designed. And this way all USB devices can interoperate with each other because they use the same type of connector, the same kind of electrical specification. Digital subscriber line, or DSL, has a physical layer. Cable modems has a physical layer as part of the DOCSIS standard. And even good old-fashioned dial-up telephone modems had a physical layer as part of the V92 standard. In wireless devices, we have other standards of physical layers. So for example, for Wi-Fi or 802.11 devices, we actually do have a couple of different physical layer specifications depending on the standard revision. Bluetooth specifies its own type of physical layer, as does the GSM Mobile U interface, or the UM interface, for 3G cell phones. And for 4G LTE cell phones, there's another LTE physical layer with its own specifications. Fiber optic also has specifications. For example, wide area fiber optic systems, or SONET rings, have their specifications. And even the combination of optics and wireless with the infrared light-based wireless devices, wireless infrared, or IRDA, has a physical layer specification. So we have these specifications for all of these different types of physical layers, but all of these different types of physical layers share a common purpose, and that is that the physical layer itself, conceptually as part of the OSI model, defines and provides the hardware required to transmit and receive bits over a network link. We have a bunch of different choices of physical layer. Different ones exist for different purposes, including multiple varieties of wired electric, wireless radio, and optical connections. But all of them serve the same purpose, and that is to provide the hardware layer upon which the rest of the networking system will be built.